Okay, so we're going to wrap up our fluid and electrolyte balance by talking about the homeostasis of potassium and calcium. Sodium is also really important, but we've essentially talked about that a couple of times throughout the semester, especially as it relates to aldosterone. So we've got 4 outcomes for this lecture, 2 about calcium, 2 about potassium, and really it's what are the effects of having too much or too little potassium or calcium, and how do we maintain this? So we'll start off by talking about potassium. And potassium is really important with neuron function, neuromuscular function. But if we have hyperkalemia, which means more potassium than normal, that can be bad because it could potentially depolarize the cell. When someone has hyperkalemia, they have more potassium outside of the cell than inside. And what that's ultimately going to do is that's going to drive potassium into the cell, and it's going to make membrane potential less negative, or in other words, depolarize it. Conversely, and it shouldn't be too surprising that if we've got hypokalemia, the reverse is true. Where now we've created a bigger gradient, and so potassium is leaving the cell. And when we leave the cell, we're going to be hyperpolarized. And the problem with that is it's going to make it more difficult for us to reach threshold for an action potential to occur. When it comes to maintaining potassium concentration, this is something that's done by the urinary system. We've talked about aldosterone before, and we've talked about how aldosterone manages sodium concentration. But if you remember, aldosterone is secreted when we have high potassium concentrations. Okay, so this causes us to hold on to sodium, but the other thing is that it actually causes our kidneys to secrete or remove, eliminate, get rid of potassium. Okay, so if I have high levels of aldosterone, I'm going to secrete potassium. If I have low levels of aldosterone, I'm going to be more likely to hold on to that potassium. And remember, this is the potassium that's outside of the cell. We're not really affecting the amount of potassium inside the cell so much. Now with calcium, we know that calcium is found in the bones. That's where most of it is. It's important for blood clotting as well as neuromuscular excitability. Remember, we need calcium to go inside the cells, so exocytosis occurs and so on and so forth. And then when it comes to muscle, more calcium, more cross bridges, more force. Okay, if we have hypercalcemia, which means that ultimately will cause more calcium to go inside cells, we will or it's potential that we could experience tetanus, where we have that constant muscle contraction. Because so much calcium's in the cell, we're opening up, or we're making available actin and myosin so they can bind. So again, more cross bridges, more force. All right, or you could have hypocalcemia. So that means you have much less calcium than normal. So that means the gradient's going to be smaller when a calcium door opens, and so an action potential comes down. That calcium is going to move into the cell more slowly, so exocytosis is going to happen more slowly, and also there's not going to be as many cross bridges when when we're activating a muscle. All right, we got weird animations there. Sorry about that. So when it comes to calcium concentration, the main hormone that affects it is parathyroid hormone. And remember, this is released from the parathyroid gland. And this is parathyroid hormone is released when we have low concentrations or low blood calcium. This causes parathyroid hormone causes bone to give up calcium. Okay, your bones are made up of a lot of calcium. They store a lot of calcium, but it's okay. They can give up some calcium. We don't want them to give up too much, or then we can experience osteoporosis. But parathyroid also causes the kidneys to reabsorb calcium. So any calcium that makes it into the filtrate, or we're going to be more likely to absorb that, or reabsorb that, and then it also makes it easier for us to absorb calcium out of our small intestines. So ultimately, these are the 2 things I want you to be able to do. Describe how we can achieve potassium and calcium homeostasis.